Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. So today we've got Aditya who has completed the course Linux Basics, and you'll be giving a presentation. First of all, you do a demonstration on the real robot, then eventually we'll get into the details about his code base and how he managed to complete this project. Alright, so now I'll hand over the floor to Aditya, and you will begin his demonstration. So over to you, Aditya.
Yes, sir. So I am currently here for the presentation of my Linux for robotics course. So this is my screen. So first of all, I am going to connect my robot. So turn on so that I can run my obstacle avoider batch script. It's connecting. Yeah. So finally it is connected. So first of all, I think I need to run my uh, shell. Yeah. So leave. Let's see. Linux project folder, Linux project, and /. Uh, ls. Right. So I just need to run my Python script robot interface.py, which will basically intercept my obstacle avoider program and send it directly to the robot. So I'm just running my robot interface script.py.
Alright.
Yeah. So getting ready in 5 seconds. Perfect. It's ready. Now I just need to run my obstacle avoider.bash script, which is also present in my ROS2 src uh, Linux projects / obstacle avoider. Yeah, this is my bash script,
Okay.
which is basically uh, enable the robot to move on this particular arena.
Alright.
As you can see, this is the small city lab, which is the real-time robot interface. And let me hide the screen. So as you can see, the robot has already started moving. I'll run the script for a while and then I'll explain you how I wrote the script
Okay.
and how is it really communicating. So when write command is executed, and there will be one more time using turn write command. Right. Now it will move forward. And in this way, it will basically avoid all the obstacle, including walls and other obstacles.
Alright.
So meanwhile, while the script is executing, I'll just explain it. So this is a bash script basically, and on the robot there are basically sensors present which will capture five values in total: uh, front front value, front left value, front right value, left scan range, and right scan range.
Okay.
Depending upon what the values are, it will take the decisions whether to turn right, whether to turn left, or to move forward.
Okay.
Right. And it will, because there is a while loop, so it will keep on executing that particular step.
Alright.
Right. So I think it's the right time for the script explanation.
Yes, let's get into it.
Let's get into this. So I just stop this and I just exit this as well. So yeah. Yeah. So this is the obstacle avoider.bash script, which I learned how to write this particular thing. And uh, I started this robotics thing from the construct.py, so I'm just a beginner. So as I've said that these are basically five values which this thing is extracting. Uh, on the top, I have included this robot functions. This is also a bash script basically. If you can see this robot functions.bash script, there are a number of getters and setters. So getters and setters are basically functions getters are basically functions which will get the value, and setters are function which will basically set the value. So when I say just get the value, so basically this is the get scan left array index. So it will get the value of scan left array index. And if I will show you, so if like here I'm getting the get scan left array index, and it will assign the value to the LSR variable. So now I'm here using five variables, and now so what is happening here is there are three variables: front left free, front free, front right free. So these variables will tell the script that whether my front is free, whether my left is free, or whether my right is free. So if the FLSR is greater than threshold, if my front left scan range is greater than the threshold is basically set to 0.33, 0.300, right? If that is FLSR is greater than threshold, then it will say that okay, front left free is 1. And if it is not, then it is 0. If the front scan range is greater than threshold, then the front free is 1, else it is 0. And if the front right scan range is greater than the threshold, which is 0.33, it is set to 1 and else it is 0. Now this is my if else function, which will basically decide whether to turn right and left and right or move forward.
Right.
So if you see the first if statement, so if the front left free is not 1, if the front free is also not 1, and the front right is also not free. So not 1 in the sense front left is also not free, front is also not free, and the right side is also not free. So in that case, you cannot move forward. So you will take a right turn or a left turn.
Right.
So then I will check the left scan range, whether left scan range is greater than right scan range or not. If left scan range is greater, then I will take a right turn. Else I will take if left scan range is greater, I will take a left turn. Else I will take a right turn. So now how am I taking the left turn basically? So I am setting this angular velocity to 0.31416, which is 0.31416 meters per second. Radians per second. So it will basically this command basically execute and set the angular velocity of the robot to 0.31416 in case of a left turn, and minus 0.31416 in case of a right turn. And it will turn left for 1.5 seconds, and then it will again set back to 0. So the next else condition is if the front left is not free, the front is also not free, but right is free. If the right is free, then you just need to take the right turn using the appropriate command.
I see.
And if the next condition is if the left is not free, if the front is free and the right is not free, then it is obvious that you just need to move forward. Now for moving forward, what I am doing is I am just calculating the distance to move. When I am calculating this, basically I am calculating the FSR minus threshold. How much it is free to move. So for example, if the ball is way ahead, then the distance will be large, hence the ball will also move a large distance. So now FSR minus threshold, time to move, I am just dividing this by 0.100, which is my 0.1 meter per second. This is my this is my linear velocity. So I'm just using this physical distance time formula, and I'm calculating the time. So I'm like how this is useful. So I'm just setting the linear velocity to 0.1 meters per second, and I will sleep for that particular time, which I just previously calculated in this particular
Mm-hmm.
right. And then after that particular time, I will again set the linear velocity to 0. Right.
Right.
This way, I will be able to move forward
Okay.
for that particular distance using that speed is equal to this time formula.
All
So
right.
yeah. So next if condition is uh, if the front left is not free, if the front is free and front right is free, then you just need to take the right turn and so on. In this way, I'm just doing this thing, and this is the end of the obstacle avoider dot bash script, which I wrote in this project.
Mm-hmm.
So this is this is basically controlled by the robot interface.py, which is a Python script. This script basically initializes all the commands to zero, and this script is also responsible for uh, intercepting my commands to the robot and intercepting the robot's response. But I don't have that much idea of this particular because it's not taught in our course.
Mm-hmm.
I think it will be taught in my I think Python course for Python robotics course, which I'm going to take the next. Uh, so yes,
All
this is
right.
my presentation.
All right. I see.
Okay.
Very well done on the details of the base script right there. So I'm gonna ask you just a couple of questions. One of them is probably very general. What do you think is the significance of using base scripts in robotics, for example? From your understanding, what is their
Okay.
significance? Yes.
All right. So basically, for example, if you see this is a bash script basically.
Mm-hmm.
So if you don't use a bash script, you can directly execute this command with the terminal.
Right.
So I need to write this set CMD linear velocity to zero. Then I will write the angular velocity to zero. I will set the threshold by 0.3600.
Right.
Right? You can execute commands on the terminal. But what bash scripts do? Bash scripts automate the process.
Right.
This
Right.
script is basically automating all the commands which I elsewhere I have to write by my own hand manually.
Right.
It's a
Okay.
tough process,
Very good.
tough thing,
Very good. Very good.
right?
Okay, the next question I'm going to ask you is concerning some detailed stuff about it. So, you realize that every time you pass a variable, right, or to your base function, where you put a dollar sign before, what do you think is the significance of that?
Right. So basically, this is calling this get scan left function
Mm-hmm.
and assigning the value of to the LSR value,
Mm-hmm.
right? This is what it is doing, and this echo function will just decode this intercept this LSR. What is the value in this LSR at that particular moment, and print this left scan range, for example, 0.30.
All right.
That
So,
way.
so you are you saying that it is responsible for executing whatever is next to that dollar sign? Is that what you're saying?
Right. So this get scan left range, it's not defined here. It's defined in this reward function bash
Right.
somewhere near here. And by calling this function, this particular command gets executed.
Right. 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 I see.
Right. So this is a ROS command, and it will fetch the parameters according to that.
Mm-hmm. Okay. I see. I see. Let me see. Do I still have another question? Okay. In relation to your usage of base scripts, right? When you use echo, what would you compare that to in general programming, right? The effect of the echo command, right? What would be its
Yeah.
analog in other programming languages, right?
So I think it is like print function. It
Okay.
will print the particular value on the screen, whatever you put inside this quotes.
Yes, good. That's what I wanted you to get. Okay. So well done on that. And I think we done. Your presentation is very good. You have shown that you understand the details and critical usage of base script and also its significance in robotics in general and our career to develop robot software. So what we'll do is let me just do a wrap up and then we can conclude our meeting on Zoom. All right.
Right.
Alright everyone, so this was Aditya's project on Linux basics, and I highly recommend that if you would want to take up the path on the journey to certification using some of the courses that we do offer, have a go, and again, you won't regret it. It will aid your knowledge. So until next time, keep pushing your ROS learning. Bye bye.